All right, this one's a little crazier. It says a particular die has the following properties. On any roll, the probability of rolling either a 3, a 5, or a 1 is 1/2, just like it would be with an ordinary die. Moreover, the probability of rolling a 1, 6, or 4 is, again, 1/2. However, the probability of rolling a 1 is 7/16, not 1/6, as you would expect. From what we know about this peculiar die, what's the probability of rolling either a 3, a 5, or a 2? So if I look at my choices here, this one has a 3, 5, or a 1. This one has a 1, 6, or a 4. Notice that those are the total opposites of these three right here. So my probability of getting a 3, 5, or a 2 is 1 minus the probability of getting my 1, 6, or my 4. Well, if my probability of getting a 1, 6, or a 4 is 1/2, then I'm going to have 1 minus 1/2, and my answer is going to be 1/2 then. So if I'm looking for it not to be that, I'm going to do 1 minus that other probability. Now the next one wants the probability of just getting a 3 or a 5. I know that if I'm going to get a 3, 5, or a 1, my probability is 1/2. What I want to do is subtract the probability of the 1, which is 7/16 then. So I know that 3, 5, or 1 gives me a probability of 1/2. I'm going to subtract the probability of just getting a 1, 7/16. And so if you take 1/2 minus 7/16, hopefully you get 1/16, right? 1/2 is the same thing as 8/16, and 8/16 minus 7/16 would be 1/16. Okay, so number 17. Our peculiar die has the following properties. On any roll, the probability of getting a 2, a 3, or a 1 is 1/2. Moreover, the probability of getting a 1, a 5, or a 6 is again 1/2. However, the probability of rolling a 1 is 7/16, not the 1/6 we would expect. So we want to find the probability of rolling anything but a 1. If I want to find anything but a 1, I can take 1 minus the probability of getting a 1, right? I'm not going to get a 1, so I'm going to do 1 minus the probability of getting a 1. 1 minus 7/16 then is going to be my problem. And if I take 1 minus 7/16, I get 9/16, right? 1 would be 16/16. 16 minus 7 gives me 9/16. The next one, we want the probability of rolling just a 4. Probability of rolling a 4. I don't have a 4 on any of my lists. So, what I want to figure out is the probability of doing all but the 4. Which means, again, I'm going to do 1 minus something. So, if I'm going to do all but the 4, I know that the probability of getting a 2, 3, or a 1 is 1/2, right? The probability of getting a 1, a 5, or a 6 is also 1/2. But notice here, I've got the 1 in here twice. So I have to subtract off that probability of just getting a 1. And so my problem's going to look like that. If I'm going to get all but the 4, I'm going to have every number except for the 4. And since the 1 repeated, I've got to subtract it off my problem. So you're going to do 1 minus, and in parentheses, 1/2 plus 1/2 minus 7/16. And you get?
437.
I don't think so.
1.
Nope, I shouldn't get 1. If I look at this, 1/2 plus 1/2 is 1. So I'm going to have 1 minus 1, which would cancel out, minus a negative, going to make that a positive. I should end up with 7/16 when I'm done. So on your calculator, you should put 1 minus parentheses, and then do all that in your parentheses, close your parentheses. Try it again. See if you get 7/16. Or you could do the 1/2 plus the 1/2 minus the 17th, and then 7/16, then 1 minus your answer. Are you getting 7/16? Yes, no, maybe? Yep. So put 1 minus, parenthesis, and then you're going to do 1 divided by 2 for 1/2, plus 1/2, minus, or 7/16. Close our parenthesis, and what do we come up with? Oh, it gives you the decimal. On this, to change it from a decimal to a fraction, you hit the math button, and then number 1 for fraction, and enter. There it is. Ah, I can see why you're confused. The calculator was giving you a decimal. Alrighty. Number 18. Again, we have our peculiar die. Peculiar die has the following properties on any roll. The probability of getting a 6, a 2, or a 1 is 1/2. Moreover, the probability of getting a 1, a 4, or a 5 is 1/2. This time my probability of getting a 1 is 1/4, not the 1/6 as we would expect. So we want to first find the probability of getting a 3, a 4, or a 5. If I'm going to get a 3, a 4, or a 5, which one of those can I use? I'm going to use this first one and say that it's not the first one, right? If I don't get a 6, 2, or a 1, that means I've got a 3, a 4, or a 5. So I'm going to do 1 minus that probability of getting our 6, 2, or a 1. Well, the probability of getting a 6, 2, or a 1 was 1/2. And so 1 minus 1/2 would give us a 1/2. So if the numbers are on my list are exactly opposites of one of those choices up there, I can do 1 minus that. It's not those numbers. What is the probability of rolling neither a 6 nor a 2? So if I want neither a 6 nor a 2, since this is 6, 2, and 1, what could I do? I can take my probability of getting a 6, a 2, or a 1 and subtract the probability of getting the 1, right? Because I don't want the 1 there. I want just the 6 or the 2. So probability of getting the 1. Now again, this says neither the 6 nor the 2. This is going to give me the probability of getting a 6 or a 2. So I'm going to take 1 minus that answer when I'm done. So probability of getting a 6, 2, or a 1 was 1/2. The probability of getting a 1 was a 1/4. And so I'm going to do 1 minus the 1/2 minus 1/4. 1/2 minus 1/4 is a 4th. 1 minus 1/4 should hopefully be 3/4, right? So here we wanted neither the 6 or the 2, so we found the probability here of getting the 6 or the 2, and then again 1 minus that since we wanted neither of those. Those ones will probably take you some practice, I'm guessing.